Hi everyone. So the last video I made about Rust was interesting. I think a few people might have disagreed with my opinion. So one comment from that video kind of stood out to me, and that was that, oh, you can write Rust in the style you want. You just, you don't use iterators, don't use inferred types, things like this. So I took that as a challenge. So let's write Rust in my style, unidiomatically. So for this project, I'm going to take my compiler project from Zig and port it over to Rust. And that's what I've done. My compiler project itself kind of violates a lot of principles that a lot of people use to make compilers. For example, AstNodes. They're normally inheritance-based in C++ with about 80 different members. And then you'd handle these with some kind of switch statement. I didn't do that at all. I just thought this was way too complicated, over-engineering. I have one node and just tag it with an enum. That's it. And for anyone watching, when I say enum, I mean namespace constants to integers. I don't mean tagged unions. So here are some rules I kind of set myself. So number one is no tagged unions. Result type, option type, enum. Nope, can't use them. Next, no iterators. If possible, try not to use iterators as much as possible. Use index-based loops. Number three, no inferred types. I hate them. Number four, no function call chaining, i.e. function-call-ception. So I can't do anything like this. Number five, try not to use traits at all, if possible. And number six, write procedurally. So let's see how this looks. Alright, so here's the project. Let's look at main, shall we? So you'll probably never see more readable Rust code than this. So we start off, I'm using a string here. I mean, people are probably going to say, oh, well, why are you using a string? Oh, I don't know, I'm just lazy. I just felt like doing it. I probably could use I don't even know what do you even call this? An @str. Do you even have a name for this? @str. I don't know. Anyway, people say you should use that. I don't care. Anyway, so I call this, and I have probably the most trolling thing ever. So this basically just looks like C. Just looks like C, and it's the most simplest code ever. So basically, just pass them to tokens into a vector of tokens. We have an error. We see if it's not. We see if it is an error. We print it if it is and return. And then we go to AstNodes. We get another error. We see if it's an error. We print it if it isn't. Print tokens. I have to print tokens multiple times. Why? Because Rust doesn't have defer. Why not? Good question. Defer would make this a lot easier because you literally just do this. Defer. And then put this here. And then you write it once. But no, I've got to write it 3 times because Rust doesn't like it, apparently. Anyway. Then, yeah, string, convert it, and then see if there's an error. If not, then we just print the code, and that's it. So I'll show you the output of this. So here's the output. I mean, I got loads of warnings, but of course I'm going to get warnings. Do you think I care? So this is the input code. And it goes through and then passes it into this. I'm converting to Go right now because that's what I chose. That's what the compiler was doing. I mean, originally my intention was to convert to LLVM later, but it converts to Go at the moment, and all I have working right now is the printing version. And we have the ASTs working and the tokens working. So everything works, and it's really fast, actually, in 0.5 seconds. It's not much anyway. Anyway, so to start the troll, here are my enums, actual enums. So to do this, I actually created a Rust enum generator. I'll show you this. So basically, I put in something like this, right? I put in whatever you want. Say you have something like this, and you want to make it into my form of enum. I just hit convert, and it converts it into this. My forms of enums, which is kind of trolling. I wrote that in C#. Anyway. So I'll show you them. So first we have token type, which is basically a struct with constants to i32. That's all it is. Why? Because enums in Rust aren't actually enums, they're tagged unions, and you have to write this nonsense, which I'll probably show on screen. Every declaration has to have represent i32, derive debug, derive partial equals, and you have to spam it every time. It's like a Monty Python sketch. Spam, 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 derive spam. I don't like that. I just basically just put this in as it should be, and then it converts it for me. And then I can print it with token type to string, and we're using a match case like that. And then I can use these like this. Say the errors, for example, parse errors. They're just this. I just have a list of errors, and then I can print them. So I go back to here, and it's an I32 because it has to be. You could say, oh, it's not type safe. It's an I32. Yeah, I don't care. Rust doesn't have enums, so I have to do this to actually make them. Parse error none. We set it to that, and then we print parse error to string. And we just check if it's null. The thing is, in regular Rust, you can't do this. You have to have derived partial equals, otherwise you can't convert it. Anyway, I don't care. I'm intentionally doing this. I don't care. I just want an enum. I just want a namespace constant to integers. That's what these are. All right, let's get to the parsing code. So the parsing code is actually probably the area. Well, actually, this whole project is actually really, really, really hard to write in Rust, because if I show you the AST node types. So this is the AST node type. Basically, we have an AST node, and itself links to left another AST node, middle another AST node, right another AST node, and then children is a vector of other AST nodes. So it's basically a linked list. And linked lists are basically kryptonite to the borrow checker. It just doesn't work at all. I did have to implement clone just because it was yelling at me if I didn't, which is annoying, but anyway. So I failed the trait. I had to write some traits. Anyway. But yeah, try to write this in idiomatic Rust. Good luck, honestly. I mean, the idiomatic way would be kind of to do... It looks really horrible. Because, I mean, in Zig, this looks like this. It would be optional pointer to AST node. That's the Zig code. The idiomatic Rust would be option this box AST node. I mean, which one looks better? I mean, this one is literally just 2 characters. This is... Anyway, so I'd rather not have box and optional. And we can't use tagged unions anyway. Option is a tagged union. So we have to use @mute, and we have to use unsafe everywhere. But the reason that works is because you can make them mutable. They're mutable by default. And we have this thing, create raw pointer, box into raw, box new variable, which is... Anyway. I don't know why they call it box. It's a pointer. What the hell is a box? It's a pointer. You mean pointer? Anyway, let's go to the parsing code. The parsing code is actually very, very hard to write in idiomatic Rust. So what we have to do is we have to go through each character. Say we find an F, right? So the first character here is an F. So we go through that. Then we have to make that a word, right? So we have to go... We go F, N, and then, stop. Okay, we've got to save this as N. And then we go to this, we start at this question, we go to this character. But we're not on this character. It's an iterator. Iterators go, one character each. What happens if I want to look ahead or skip characters? How do I do that? Do I have to use peek, and then, like, peek to spam peek in a while loop? Like, how do I even write this? So basically what I've done, I've just copied the Zig code anyway. So we have first with this, we have a vector of tokens, and we have the code as bytes, because we need to get the U8, we need to go individually each character. So we get the code as bytes. We have this parse data, which is just there to just hold data, and we just pass it. We pass it by immutable reference. So, because I don't want to spam about 10 different parameters, so I just have this just for that. I mean, this is basically the same as the code in my Zig series. It's just in Rust. No inferred types. I also hate this. This drives me crazy. I hate the gap in between. Like, why are you putting a gap in between? I didn't write the gap. Why are you writing a gap? It's idiomatic to write a gap. You don't even write types. Why do you care? Anyway, so yeah, get the length, and then we loop. And then we call another function. I like to extract functions. That's what I do. So we go to here. We pass @mute parse data. We process the character. We see if we should skip, which again does a lot of stuff, because we could basically it could increment the index. If we have here, we have the index here, token. Can't even find it. We've got last token, character index. We have the character index, which we increment in some situations. So was it a comment? Character count +1 plus equals 1. here, character index plus 1, character index plus 1. Basically, how would you do this with an iterator? Like, if it's a space, skip, and then if it's a space, you got to... Anyway, then we basically process the token. We get the token. Again, I don't like the space here. We get the token, and depending on what it is. So is it an operator? Is it a separator? Is it a word? Is it a string? If it's a string, we do this. So we're basically looping inside a loop. How would you do that with an iterator? I challenge anyone to write this parsing code the way it is without changing my data structure in idiomatic Rust. It'll be a nightmare, a complete nightmare, honestly. So yeah, we're looping and then looping again. And then we just simply, well, if it's an error, we return an empty token. The way we kind of do errors is just we pass the int as an mutable i32 and then just set it to the parse error, which is just a struct holding an integer. Because that's all enums should be anyway. They should be integers. And that's basically how it works for everything. Read separator, exactly the same. Read char, exactly the same. Read operator, exactly the same. Read word, exactly the same. Right. And then again, the token type, get token type is an i32. Anyway, so that's the parsing code, which converts into this, converts into these, which also it saves the name and the char number. Anyway, then we go to the AST, the building AST nodes, which again, we do exactly the same thing. We have the AST data for everything. Unfortunately, like, I kind of had problems with the borrow checker, because of course you do with this stuff like this, because it's basically a linked list. You're going to have problems with the borrow checker no matter what you do. So I have to clone a lot of the time, which isn't very efficient, but it's not my fault I had to clone all the time. It's the borrow checker's fault. Anyway, so we have this thing indexed before, and we were using indexes. I'm not going to use iterators. Sorry, not going to use iterators. And then if it's an error, so we have this thing is an error. If it is, then we print the error and return. And we print the AST nodes cloned, because of course we do. And we return the AST nodes cloned, because of course we do. Well, in theory, to avoid that, you could create that in main. You could create that here and then pass that by reference. But then you put it into here anyway, so that would kind of trigger the borrow checker, because it only exists in AST nodes.s. So how would you return it anyway? You kind of have to clone it. It's like the borrow checker really just annoys you all the time with this stuff. Like, but you can write Rust in the style you want like this if you don't use any standard library functions or any dependencies, or if you don't write code with anyone else. You could write in this style if you want, but you can't avoid the borrow checker. That's always going to be there. Then, okay, so we're only doing functions because I couldn't, like, this took me so long to do, I just couldn't be bothered. So we're only doing functions at the moment, and we're only doing print inside functions. So, yeah, var name token, get token, which, yeah. So again, I have this, implement lifetime suck, because they do suck. I mean, the problem I have with lifetimes is I find them pointless, because if I have a use after free, so I tag something with a lifetime and then use after free. The borrow checker still catches it, so why am I tagging lifetimes? Good question, right? The borrow checker still catches use after free, so why do you have to tag lifetimes? It's for the compiler only. It doesn't actually make your code any safer. Okay, that's why lifetimes suck. That's why I've tagged every lifetime with the lifetime suck, because they do. So I get the token, which basically just returns an empty token and gives an error code, which means I have to check the error code. It's a lot better in Zig, because Zig just uses try. You just get rid of this entirely. Instead of is error return, you just put try here and it returns for you. Of course, Rust, the Rust station will say, just put question mark and use result type. It's a tagged union. I can't. And I don't need to use tagged unions. Okay, then, we see if it's an identifier. And we're just incrementing. Incrementing basically returns a bool to see if it's an error, because it could go outside the bounds of the length of the token list. So I just return a bool and then return if it's false, basically. And again, I'm not going to do this because you're going to, oh, you should do that. But that's harder to see. Because when I'm skimming through the code, I don't see this. I do see equals equals false. It is just prone to logic errors. I'm not going to write this. So if it's true, I will just do this. If it's false, I'll do this. Because I can read it at a glance without having to, like, has that got a clean? No, that's too small. I want to avoid logic errors, so I'm going to be explicit with my bool checking. We're basically just checking the type, really. Increment, check if it's a left parentheses. Increment, we get the parameter nodes, we fill the parameters. We see if it's an error again. If we return. We expect right parentheses. Increment, we expect left brace. Increment, we build the body block. Building the body block was kind of annoying as well, because we're almost doing the same thing. It's the same code, really, and we only have print line. And print line going to process print is a mess. Kind of. Fill in the node in brackets, ASTutils. I mean, this is basically just C code written in Rust. That's all it is. It's funny, isn't it? I imagine the comments on this video are going to be pretty funny. I don't care. I mean, you take yourself too seriously, man. Like, come on. It's just a language. Like, I can write how I want, can't I? Then, sorry, I'll go to converting. I mean, converting is almost exactly the same. The problem is with conversions is you got to deal with pointers, because one other thing I had to do, I'll see if I can show you. When I create the pointers, I have to, well, I just put this thing create raw pointer just because I was getting annoyed for it. You basically have to put it into a box and then put that box into raw, and it'll be null by default. I guess that's why it works. But basically, I have to dereference all these pointers, and I got really annoyed, and I kind of just ended up cloning a lot of stuff over and over again. I have this thing code builder, which is basically, again, implements clone. I failed. I have to use traits. Sorry, I failed. But just, yeah, loads of inbuilt functions just to append stuff easily, because we just want to build stuff. You could use a vector of U8, but it's just easier just to make a struct that does it for you, which is actually copying directly from the Zig code anyway. Right, so yeah, we just put everything in. I didn't want to, again, to have defaults. You need to use traits. I'm not using traits if I don't need to, so I'm just going to put all the defaults in. This is basically, I mean, I am kind of allocating every function call, but I don't know how else you could do it, because it has to persist. Because I can't use an @str or whatever you bloody call it, because it's a stupid name. I mean, really, like @str. I could use that, but it can't persist, because the error function thing has to go all the way back until the start of go convert. Has to go all the way back to the start of it, and I use it in every function. So could I really put an @str, because it wouldn't work? Because it wouldn't persist in every function call later. Would it? Anyway, so I make it a string every time. So I allocate it on the heap every time. Who cares? Get the node count. If it's 0, we return an error with string new, because I'm weird. Well, null doesn't really exist. They use tagged unions. I can't use tagged unions, so I have to just return a generic string new, and then return an error. Convert. Why are you doing this? Like, oh, we have to use function. No. Bad Rust. Same line, please. Code builder append line. We're just appending this. We just leave. I mean, I think I did have one in the other one that just checks that for me, but doesn't matter. Previous index. Yeah, I did link this because I couldn't be bothered. I could do it later. I didn't actually get a convert error, so it doesn't actually matter, but I could do it later. Which means I'm not actually using the code. Ooh. Anyway. Well, it's exactly the same as before, and then we clone it, because we have to clone it, and then we return it into string, because the bar checker was annoyed if I don't do this. If I do this, return generated code, say, what was it called? Code builder dot into string. It's not going to like it. Moving it. Just leave me alone. Do this. Get out of my life. Then yeah, the same. So we are basically only doing function calls, because I couldn't be bothered to do the rest of this thing. That's all. We write the function name and parameters, which is fun. We have unsafe because of course we need to have unsafe because we're using raw pointers. It was the only way to get it to work other than using box and optional, which is a tagged union. But where do we actually have the? I don't remember where we actually have the raw pointer access. Yeah, function name pointer. I got kind of annoyed by this, to be honest. I mean, the syntax in Rust is kind of weird. You have to put it in brackets and then .clone. I find that really weird. Just weird in general. Anyway, so yeah. Oh, wait. Inferred type. Sorry, you caught me. Oh. It's an @mute token. You caught me. I didn't use an inferred. I used an inferred type. Anyway, yeah, so it's an @mute token. So I have to see if it's null. That's basically my safety. Is every time I have a token, I have to check. Every time I have a point, I have to check if it's null. If it is null, we return. Otherwise, we do this and clone it, because we have to clone it because the bar checker is annoying and won't shut up, because it's basically a linked list. We get the type chest about print type. I believe this. Yeah, it just kind of again, you've got to clone everything. You got to clone. You clone this, and then you clone that, and then you clone this, and then you clone that, and then clone this, and then clone that. And then I challenge anyone to write this in Rust. It's basically a linked list. It's a nightmare to actually write in idiomatic Rust. Here I use format to actually format it with the function name. Again, if middle's not null, equals false, because I'm not going to use this stupid negation. Print parameters and print the parameters, which is actually really complicated to do. Well, the zig code is actually way more complicated because I actually use a slice of slices, which I really shouldn't have done. But we also have to kind of recursively look for the base node, because in theory, it doesn't matter in the code I use, but it could be something like this with a pointer to an int. So you got to kind of go skip this, put this as the base type. You have to kind of find the base type. So you have to use this weird stuff. You let me base type pointer equals to, oh, I'm using an inferred type. Oh, sorry, it's inferred. @mute AstNode. Sometimes I forgot to do it. Anyway, so we check if that is null. If it's false, then we just put it to that. We're just getting the base type, but we shouldn't even actually find it in this code anyway. So yeah, where am I? Go to this. We write the parameters. We increment the index node. Index count. I think, yeah, that's actually just for tabs. I don't actually use it in this. Who cares? Here I'm dereferencing a pointer and cloning it, so I have to use unsafe. Process the body. Because in theory, what people should tell me is, oh, you should use a reference. But if you use a reference, where does it owned? It's just annoying. It's just annoying, especially when you're using raw pointers. It's just like, it's not really designed for this, and it is a linked list. So, yeah. I mean, so I've written this code in C# and Zig, and now Rust. Rust was easily the hardest to do, because the bar checker just doesn't shut up. It just doesn't shut up about this, because it's a linked list. It's like the most annoying thing to do. Again, yeah, we're just looping through, getting the child, cloning it, because of course you've got to clone it, and then passing it in here. Process function body node, we have unsafe, of course we do. And then we just literally just processing the print. And the print was actually really annoying to do, because in theory what I should do is have kind of print expression, which I didn't implement because it just takes too long. And I basically just see if it's a string literal. If it is, I just put this here. That's kind of the alternative, because I'll show you the Zig code. Alright, so here's the Zig code. I mean, it's basically the same. If you look here at process print, we have process print. When we go down, add tabs, child count. We do this if it's basically if it's new line. If it's not, that's an error. And then here I kind of create a slice of slices, which is not a good thing for me to do. It's very complicated to do that. And then I just, but here I basically have a thing, print expression, which goes to this thing, which has all these stuff: binary expression, bool expression, identifier, float expression, minus, char, literal, function call, array group. You think I'm going to implement all this in Rust? No. chance I'm doing that. So I basically just, where are we? Of course, I would have to copy all of this if I made this a full project. But I'll put the code in the description, and if anyone wants to make this idiomatic Rust and torture themselves trying to make a linked list work and a token parser work using iterators, be my guest, because I'd love to see that kind of code and see you torture yourself trying to write this in idiomatic Rust, because it's not really designed for it, to be honest. Yeah, we're just appending, basically, that's it. And that's it working. I also have the print, which actually the print was actually really annoying to get the printing to work. So we have print AstNodes. So first we call it, we just printing AstNode in grey. The print codes are basically just these print codes. They're just, I can't remember what they're called. But anyway, back to debugging. So again, we loop through. Oh, I'm using an iterator. Oh, probably shouldn't use an iterator. I actually fixed that now. Does me not using an iterator. It's not that hard with a vector. With other stuff, it's quite hard. So first we have parseNode as reference, because the original ones are reference because they're not pointers, but the nested ones are pointers. So I have to have two functions. Just kind of how they're basically a copy of the same the same thing. Here I have to have iterator.collect. Just like, honestly, it's just because it's kind of a so in theory I'm kind of violating my own rule. So I'll fix that right now by making it an iterator. The problem is I have to use iter. Okay, so I'll fix it because I'm using a function call chaining. So let's say let padding iterator equals padding builder by 0.padding length dot to iter, or iter, like that. Then I'm going to get the type, whatever that is. It is an iter, and it's going to give me an error because it doesn't know what iter is. It doesn't know what iter is, so I'm going to have to include iter, which is part of the, I don't even know which one it is. Which one is this? Good question. It doesn't tell you which one it is. Consider using SE collections B. Which one is it? Because it's a vector, right? Yeah, I understand that, but which one is it? This is why people don't use inferred types in Rust, because they don't want to deal with this rubbish of having to know what an iter is. But you actually learn the language if you do this. So maybe I'll try this one. See if it shuts up if I do this. Do you shut up if I do this? You do? Okay. It didn't like that though. But are actually distinct types. Well, which one is it then? It's not that one. So I have to guess which one it is. This is why people just use inferred types. Maybe it's Alright, so what actually is this? It's a vector. So it's probably in vector. There's a vec here. I don't think it's that though. Technical difficulties. Trying to not infer the type. I don't know what type this is. Maybe it's a slice. I think it's a slice. Let's try this one. Hooray! It worked! Okay. We found it. It's a slice. Unused. And then we need to go padding.collect equals padding iterator, which I didn't spell correctly, dot collect. Right? Right? I'm still using an iterator because the language is forcing me to use an iterator. I can't not use an iterator, but at least I'm not using a function called train, and we're actually knowing what the types are, and we're not using inferred types. The padding basically is just, if I show you, it's just the spaces in between. That's all the padding is. So basically we count how many indents we have, and we add padding for that. We print out the AST to string, AstNode to string, because we need to know that. And then we basically just see, we call print node as pointer, and see if they actually exist. So here they're all pointers in this one. where we have at mute our AstNode. We've got to wrap this in unsafe because they're pointers. And it's basically the same other than that, except for what we have here. If the node is null, we return, because it could be null. So we don't have any null check here, but we have the null check in the function. It wasn't too bad other than that, really. But the main problem, again, is just the fact that you have to clone everything. You know, this.clone, this.clone. The AST nodes are cloned. This is cloned, that's cloned. Everything's cloned. The only way around that would be to kind of pass it by reference, but then I couldn't pass it into the AST data, which means I'd have to pass it to this function as a separate parameter, and then I want to go insane because I have too many. Anyway, so this was interesting, to say the least, and I'm completely trolling, by the way. I did this on purpose, just to troll everyone. I don't really care about being idiomatic. I mean, look at my C# code. This is this project in C#. So this is this project in C#. It's like the least idiomatic C# code ever. Everything's static. I'm using no inferred types, like var, delete var from the language. It's trash. It's garbage. Never, like, you couldn't pay me to write this garbage. Var, no. Never. Get it out of the language. It's garbage. You're lazy. I hate inferred types. I will tell you every time I hate them. And I'm not using exceptions, try-catch blocks. I'm using enums. Actual enums, you know, the integer ones. I'm using actual enums for this, which is basically what I was trying to recreate in Rust without using derive spam. Anyway, so yeah, this is basically completely anti-idiomatic C# code. I don't write interfaces. I don't care about classes, just hold data. Most things are static. Sue me. Exceptions suck. And then I just basically copy this into Rust from Zig anyway. I mean, the Zig code looks a lot more advanced than this, actually. So here's the Zig code. We can ignore this. So we have convert code, which is the main function, which returns a string, which is actually just a const u8 slice. I couldn't be bothered to write that every time, so I just made it an alias to string. And it's basically the same code. So we have token lists, and we have catch, print the error. We have build ASTs, print ASTs, and then convert the code. We're skipping the analyze phase because it has errors at the moment. We have a few other things like print output, print to file, because this actually prints to file. But other than that, it's basically the same code. Anyway, it's idiomatic in Zig, at least. I hope you enjoyed my complete trolling. Rust isn't for me. It's not my kind of thing. It's not my kind of language. I'm fighting the language every second I write in it. This is just a troll. There are other styles of coding, you know. You don't have to wrap everything in iterators. You can use loops. You can use real enums that are actually integers. This is just my opinion. I have stupid opinions. I'm weird. I like to be contrarian. Well, I don't be contrarian on purpose. It's just kind of how I am. For example, I'm right-handed. I play guitar left-handed. Who else does that? I mean, I'm a weirdo. I'll admit it. I don't care. I literally don't care what you think. Like, it's just my opinion. Like, it can be. I mean, opinions technically can't be wrong. It's subjective. But anyway, let me know if you enjoyed this, or if you want to find where I live and throw eggs at my house. Anyway, I hope you enjoyed the trolling. See you soon.